Here's today's question, which is a long question and is worth 40 marks. In the first part, we're told that a sheet is folded in half a number of times. This function hx equals 2 to the power of x represents the number of layers after x folds. In part A, we have to fill out this table to show the number of layers after each of the first 6 folds. The first 3 folds are filled in for us, so we just have to fill in the 4th, 5th and 6th folds. Basically, all we have to do in this question is fill in the number of folds into this formula and then fill in the answer into the table. When we fill in 4 into the formula, we get 2 to the power of 4, which is equal to 16. Similarly, for 5 folds, we get 32 layers, and for 6 folds, we get 64 layers. Basically, we're just multiplying the number of layers by 2 with every fold. In part B, we have to list the elements of the domain and range of hx from the table above. In this context, the domain is the values of x, and the range is the values of hx. So the elements of the domain are 1 through 6, and the elements of the range are the corresponding number of layers after each fold. In part C, we have to work out the least number of folds that would give us more than 500 layers. In mathematical notation, this can be written as 2 to the x is greater than 500. To find the answer for this, we can use the previous data to help us. We know that after 6 folds we have 64 layers, so after 7 folds we'd have double this, or 128 layers. We can continue this until we get over 500 layers. This occurs after 9 folds, so the least number of folds that would give us over 500 layers is 9 folds. Part D is kinda similar, but this time we have to find the number of layers after 12 folds. They add another extra bit to this question to make it just that bit harder. We have to give our answer in scientific notation, where A is between 1 and 10. After 12 folds, the number of layers is 2 to the power of 12, which is 4096. In scientific notation, this is 4.096 by 10 to the 3, since the decimal point is 3 places from the end of the number, and 4 represents A, which is between 1 and 10. In part E, we have to explain this statement in terms of the question. Since hx represents the number of layers, this statement means that if the paper is folded 14 times, there will be over 10,000 layers, since 14 in this case represents x, which is the number of folds. In part F, we have to say which type of pattern this is: linear, quadratic, exponential, or none of the above. The answer is of course exponential, and this is because the number of layers doubles with each fold. This can't happen if it's a linear or quadratic pattern, only if it's exponential. In part G, we're told that after a certain number of folds there are k layers, and we have to work out how many layers there will be after 3 more folds in terms of k. Since the number of layers doubles each time, when it's folded again there will be 2 times k layers. And this pattern will repeat for the next 2 folds as well. So after 3 folds, the number of layers has doubled 3 times, so the answer is 2 times 2 times 2 times k, or 8k. So the answer is just 8 times k layers. In the last part, part H, we're told that after a certain number of folds, there are 2 to the power of p layers. Again, we're asked to find how many layers there will be after 3 more folds, but in this case we have to give our answer in the form 2 to the power of m. So we start off with 2 to the power of p layers. When the paper is folded again, we'll have 2 times 2 to the p layers. It's no surprise that after 3 folds, we'll have 2 by 2 by 2 by 2 to the power of p layers. This can be rewritten as 2 to the power of 3 times 2 to the power of p. This can be simplified even further, using a formula on page 21 of our logbooks. This formula says that when you have 2 of the same number raised to different powers, multiplied by each other, you can just add the powers together. In this case, we can rewrite this as 2 to the power of p plus 3, which is the number of layers after the paper is folded 3 more times. That's the end of this question. I hope you guys found this solution video helpful. Thanks for watching, and I'll see you guys again.